In this video, we're going to go over the solutions for 1.4 rational expressions in the day 2. So the first question says, the left-hand column gives me some common algebraic errors. And in each case, what we're going to do is we're going to test with a couple numbers just to showcase that this is not the same. Notice that 1/2 plus 1/2 here is 1, and this is different from 1/2 plus 2. So this is testing that there's an error here. Now for number 2, I can essentially go and test two numbers. I can pick two numbers A and B. So for example, I can pick A being 1 and B being -1. And so this is clearly 1 plus -1, and this is 0. But of course, this is going to be different from 1 squared plus -1 squared, which is going to be equals to 2. Kind of like the same thing works for doing the next one. So if you just do 1 and -1 here, and the square root of 1 squared plus -1 square -1. This is kind of getting difficult to put this -1 here, but this will be square root of 0, which is here of course, and sorry, this is going to be square root of 2, not square root of 0. So it will be equals to square root of 1 plus 1. And this will be square root of 2, which will be different from 0, which will be 1 plus -1. Now, A plus B divided by A is different from B, which is a common mistake that people do when they're canceling. And you can use any number in particular. For example, we use A being 2, B being 1, 2 plus 1 over 2 is of course going to be different from just being 1. This is 3/2, which is different from 1. We can kind of go with the same kind of thing here. 2 over 2 plus 1 is going to be different from 1 over 1. Notice that this is 2/3, and that's clearly different from 1. So this is the solution for this one. We're just testing that with certain numbers this is not true. So this will be the approach that you can take for testing if an expression that you think is equals to other is suspicious. You just test a couple values, and that's going to work out. Now, for number 2, we say, well, can we plug this x in this function? And let's investigate if it's possible or not. And this is very similar to the question of the domain, where we're checking if we plug one value, that's going to work out or not. So for example, if we do f of 3 here for this function, this is the square root of 2 plus 3, or it's the square root of 5. So that's completely fine. So this one is okay. Now for B, it's not possible because g of 3 is not going to exist. So I'm going to write DNE, or do not exist. Notice that that is because 1 over 3 minus 3 doesn't make any sense. I will be dividing by 0, and that doesn't exist. Okay. Now, h of 3 has no problem whatsoever, because although it's 3 minus 3 on the top, on the bottom is going to be 9 minus 4. And so I only get 0 on the top over 5, and that's going to be 0. So that presents no issue. You can have 0 on the top, just not 0 on the bottom. Now, number 3 is rationalizing the numerator. And this is a very similar expression to one of the things that we had before yesterday. Now notice that to get rid and rationalize this numerator, I'm going to multiply by the conjugate, which is this piece. So I'm going to make the difference of squares by multiplying by a square root of x plus h plus a square root of x divided square root of x plus h plus x. Now notice that this is kind of like a term a minus b, and this will be the a plus b situation. And so because we're doing a difference of squares, this is going to give me the square root x plus h squared minus the square root of x squared divided by h times x plus h plus x. Now notice that you can cancel out the root with the square roots, and then this is going to give me x plus h minus x divided by h over a square root of x plus h plus x plus the square root of x. And so then x goes away with x, and then I'm left with h on top over a square root of x plus h plus the square root of x. Now I can cancel h, since h is a similar thing here. And that's going to give me 1 over x plus h plus the square root of x. And so this is the end of the rationalization here. Now, for question number 4, we have two electrical resistors that has resistance R1 and R2 and are connected in parallel. So the total resistance is calculated with this expression, R being 1 over R1 plus 1 over R2. So we want to simplify that expression. Because we want to simplify, we want to try to put this term in a single fraction. And so for that, we're going to use everything that we know about rational numbers. So because we want to add with common denominators in this fraction, notice that this is R1 and R2. What I'm going to do is I'm going to multiply by R2 up and down. And so now this piece is going to be R2 over R1 plus R2. And then plus, and now I'm going to multiply by R1. And then below, it's going to be R2 times R1. So now notice that I just multiply what I needed, so they have the same denominator. And so on the next step, I can add now, and this becomes R2 plus R1 over R2 times R1. Now, because I have a fraction, and on the top I can see this as a fraction as well, I can see this 1 as 1 over 1. And so I can pretty much use properties of fractions. And so now notice that the top is going to multiply with the very bottom, and I'm going to get R2 times R1 over R2 plus R1. And so that is how you complete this. So notice that the answer is going to be here, at least for A. Now, if we have that R1 is 10 and R2 is 20, we want to know what is the total resistance. And so that's pretty much just plugging the numbers. So now R will be, R1 is 10, so I'll use this formula, right? So 10 times 20 divided by 10 plus 20. And so this will be 200 divided by 30. And so that will be 20 over 3. And so that will be the total resistance. Just plug in the numbers in here. Now moving on. And number 5, we want to simplify the most that is possible here. And so the trick is doing exactly the same thing. We're playing with exactly the same rules for the fractions. So we want to put this into a single fraction, and we want to multiply by the things that we're missing. So for example, x plus, the denominator here is x plus 5. The denominator here is x minus 3. So to have a common denominator, we just need to multiply up and down by the things that we need. So here we'll have x minus 3, and then this will transform to x plus 5 times x minus 3. Then plus, and then in the next one, I will multiply by x plus 5. So 2x plus 5, and then I'll have x minus 3, x plus 5. You see, so we're multiplying these pieces up and down for whatever we need. So now we fold this into a single expression. This is x minus 3 plus 2x plus 10 over x minus 3, x plus 5. Now we can simplify this at the top, and notice that this is 3x, and 10 minus 3 is 7, so 3x plus 7 over x minus 3, x plus 5. And so that's the end of what you can do with A. Now for B, notice that we have a 2x minus 3 square. So we want to kind of get this one to have that square too. So this one is a little bit more simple, because the only part that we're missing is really multiplying by another 2x minus 3. So then we have 2x minus 3 squared on both of them. Now this is 3 over 2x minus 3 squared. And then we can kind of fold this together now that they have the same denominator. This is 2x minus 3 squared. And the top is going to be 10x minus 15. And here minus 3. So this will be 10x minus 18 over 2x minus 3. Okay, and so that's pretty much everything that we can do in here. We cannot cancel out things or simplify more, so that's a good stopping point for this question. Last but not least, we have one of them that has fractions and different numbers. So this is very similar to the one that we did yesterday. We have 1 plus 1 over x over 1 over x minus 2. And so what we do is, again, we go for looking to have that common denominator. 1 can be seen as x over x, and this is plus 1 over x. And then below this 2, we just multiply by x up and down. Okay, so it's just a matter of making it so now we have the same common denominator. So this becomes x plus 1 over x, and now this becomes 1 minus 2x over x. Now we do the same thing that we did before when we have one fraction over other. We multiply the extremes and divide by the middle. So we have x plus 1 times x divided by x times 1 minus 2x. Notice that x is common, so you can kind of cancel that out. And then you have x plus 1 over 1 minus 2x. And so that pretty much concludes the worksheet for the day. So hopefully you got to a good point where you can use this to submit your participation. Please remember that this type of topics requires that you do a lot of practice. Make sure that if something was not clear, because I was going very quickly in this video, you pause the video, take a look. I'm trying to go step by step on each of these things, so you should be able to follow if you just pause the video or watch it slowly. Okay? All right, see you next class.